It's October time. So this is like her patent face too, kind of her usual October face. Anyway, we're going to talk about applications of rational functions in this video. And every application question that we've done so far has been pretty similar, and all of the techniques are still useful. The same problem solving techniques, even if the problems look a little different. So over here, let's read what's going on. We're reading about Naughty Products, and apparently that's an eBay retailer that resells items purchased from Fiji. They've started selling a new to market product that's new to the market. And Naughty is currently selling 2,000 units a month, and that's growing by 100 units a month. Ooh, okay, that sounds a lot like a linear function right there. 2,000 a month right now. It's growing by 100 units every month. All right. The total market for the product that they're selling is 10,000 units, and it's growing by 1,000 units a month. So the question is, what's Naughty's current market share? What fraction of the total market does Naughty hold right now? Okay, well, the market share is a fraction of the total market that it holds. Okay, so Naughty currently has 2,000. What's the total market? The total market currently has 10,000. 2,000 divided by 10,000, that's 1/5, 20%. 20% market share. Okay, and that's a new term that we haven't talked about before, but yeah, market share is just what fraction of the total market are you in? Okay, so they had, 3,000 products over 10,000 total, then that'd be 30% market share. And it's an important economic topic to consider when we're looking at this. Like the total value of the market's good because that shows kind of how marketable your product is, and then the market share is kind of like how good are you doing relative to your competitors and stuff. All right, find the horizontal asymptote and interpret it in the context of the scenario. Okay, we find horizontal asymptotes by finding long-run behavior of functions. We don't have a function yet. We're going to need a market share function. Okay, so let's find them. I'm going to do it here since we have space. Let's find the market share function. We found current market share. Let's find our market share function. So market share, we can call that MS, is just going to be how much Naughty has over how much the total is. Well, how much did Naughty? Well, they're at 2,000 right now, and it's growing by 100 every month. That's a linear function. Again, X is number of months from now. And then to be really precise, MS is market share of Naughty. Whenever you introduce variables, very, very important to tell yourself, tell other people, tell me what those variables mean. What's the total market? 10,000 right now, growing by 1,000 every month. So this is our market share function. And again, you could factor. You can't cancel yet, but if you wanted to factor, you could cancel and simplify. I mentioned that briefly earlier. So what would canceling look like? We'd have to take the greatest common factor out of the numerator, which is 100, and we're left with 20 plus x. And we'd also have to take the greatest common factor from the denominator, which is going to be 1,000. And then we're left with 10 plus x. So in order to cancel for fractions, we need to cancel for factors. We can't cancel anything inside the parentheses here. It has to be only canceling these factors. Yeah, okay, we know that, we know that 100 divided by 1,000 cancels to 1 over 10. If we did want to simplify this function, which you don't have to do, it'd be 20 plus x over 10 times 10 plus x. That's how this would actually cancel. All right, so find the horizontal asymptote and interpret what it means in the context of the scenario. Horizontal asymptote, we need to look at long-run behavior. Long-run behavior is the long run of the leading terms. Oh, let's distribute then. Our market share is 20 plus x. Hard to find the leading term of the bottom, so let's distribute that bottom. 100 plus 10x. This is our market share function. So it's going to be the same as the long-run behavior of the ratio of the leading terms. Just plus x over plus 10x. And as long as x is not equal to 0, what is this? That's 1 over 10. If x is equal to 0, we can't simplify this way. But we're only looking at long-run behavior, so it's fine. Oh, if the long-run behavior is a number, that's a horizontal asymptote. So the horizontal asymptote is when y, we don't really have a y here, is when the output, the y value or the output, our output here is market share, is 1/10. How do we interpret that in the context of the scenario? That means after a long time, the market share of Naughty is going to be 10%. Okay. The market share of Naughty is decreasing down to 10%. Eventually, if nothing changes. So even though Naughty is growing, right? The number of products that Naughty is selling, Naughty's market is growing. It's growing, you know, it's 2,000 right now. It's growing by 100 units every month. But the total market's just growing faster. Okay? So they're losing market share right now, even though their own size is growing. Because they're growing by 100 every month, but the whole market's growing by 1,000 every month. So that's why even though they're 20% now, you can see in the long run, they're going to be at this 10%. Because in the long run, the starting amount doesn't really matter. What really matters in the long run is how it's growing. All right, and you know, that's kind of a big thing for businesses in general, right? Is like, okay, where are we at now? Yeah, that's all well and good, but how are we growing is something that's really, really important. All right, so that's a cool problem where we can apply rational functions. We did average cost as an application of rational functions. Market share is another real good application of rational functions. Yeah, that's it. Let me know if you have questions. Bye-bye.